Here, I would like to talk about how shear force and bending moment act on a beam. The shear force is shown as Q in this illustration. As you can see, Q is a force acting along the z-axis direction. As previously explained, the shear stress or shear force is a force couple in the opposite direction. A downward shear force, Q, acting on the right surface causes an upward reaction Q on the opposite surface. Shear forces, which is equivalent amount, is acting on the right and left surface in pairs, facing each other toward opposite direction. This is how shear force in a beam behaves. To understand the shear forces of a beam, you must first understand the concept of the negative surface and the positive surface. In this illustration of a beam, which do you think is the positive surface? The surface on the right is the positive surface. You may more clearly understand by recognizing that the positive surface has a normal vector toward the positive direction along the x-axis. This is the explanation of what the positive surface means. The negative surface is the opposite side of the positive surface. The negative surface has the normal vector on the surface of the left in the illustration toward the negative direction along the x-axis. We define the shear force acting on the positive surface toward the positive direction of the z-axis as positive. The positive shear force acting on the negative surface is toward the opposite direction of that on the positive surface. Q in this illustration is a positive shear force. The bold arrows in the illustration are positive shear forces. On the positive surface, the positive shear force is a force toward the positive direction along the z-axis as well as a force in the negative direction along the z-axis on the negative surface. You may not understand it right away now, but you may get used to it by confirming the positive and negative of shear forces at each time as they appear later. Next is the bending moment. The bending moment causes the beam to curve. The moment acts on both the cross-section surfaces of left and right. These moments are balanced. The bending moment that causes convex downward is defined as positive moment. The convexness caused by the positive moment is towards the positive direction of the z-axis, as in the illustration. Some textbooks provide slightly different definitions of the moment and the shear force. If you are referring more than one textbook, you may find that the definition of positive and negative of these are different. Here, the definitions introduced above are to be used as our uniform manner. So far has been the explanation about the positive and negative definitions of the shear force and the bending moment.